Spanning tree BPDUFilter is Cisco's enhancement to the spanning tree that is quite possibly one of the most misunderstood features on Catalyst switches. The reason for that is that there are really two features that carry the same name, the BPDUFilter. Which feature gets enabled depends on how you configure the BPDUFilter. There are two ways of doing it. One is per port and the other one is globally as part of the portfast configuration. When configured on a per port basis, the spanning tree BPDUFilter will unconditionally filter any outgoing and any incoming BPDUs. This is the equivalent of turning off the spanning tree on this port. Contrary to this, when we turn on spanning tree BPDUFilter globally as part of the portfast configuration, no incoming BPDUs will be filtered by this feature, and BPDUFilter will filter only most of the outgoing BPDUs, but not all of them. Let me show you all this with a couple of examples. I am again going to use a very simple network here, consisting of only two switches. I'm going to have Cat1 and Cat2 interconnected with gigabit interfaces. So this is gigabit interface 01 and this is gigabit 01. In my setup, Cat1 will be the root when nothing else is configured on the network. Let's see what will happen when I enable the BPDUFilter on this port here. If I take a look on my Cat1 at the output of show spanning tree, I will see that I have only one interface that is designated and forwarding, and which is gigabit interface 01, the interface facing my Cat2. I also see that Cat1 is the root in our network. On Cat2, if I do show spanning tree, I will see pretty much similar output, except that the gigabit 01 is going to be the root port and not the designated port. That's because it's receiving superior BPDUs from Cat1. What I'm going to do next is I'm going to enable debug spanning tree events on Cat2, and I'm going to go to Cat1 to gigabit interface 01, and I'm going to say spanning tree BPDUFilter enable. BPDUFilter, to be more correct. Now, what this command does is it enables the BPDUFilter unconditionally. Cat1 on gigabit 01 is not going to be transmitting any BPDUs, and it's going to be rejecting any incoming BPDUs that it receives. On Cat2 now, we have stopped receiving any BPDUs, which means that the max edge timer will eventually expire, and when that happens, because this is the only interface that is up and we are not connected to any other bridges or switches in our network, the Cat2 is going to declare itself the root in this network. If I do show spanning tree, I will see now that Cat2 thinks it's the root. Now, if I take a look at the gigabit 01 interface here, I see that it is now designated forwarding. On Cat1, I will have the exact same situation. Now, both of these switches think that they are the designated switches on the segment interconnecting them. That's because effectively on Cat1, on this port, we have turned off the BPDUs. We have turned off the spanning tree on this port. Now, that's from the perspective of Cat2. From Cat1's perspective, this port is still participating in the spanning tree. That means if this interface was to go down, the topology change notification would be generated for this interface. And when this interface changes state to forwarding, it would still generate the topology change notification. Furthermore, if this interface was to go down and then go back up, if I did show spanning tree here, I would see that it would still have to go through the regular motions. It would have to go through the listening phase, it will have to go through the learning phase, and only then move into forwarding. So even though we say that the BPDUFilter effectively turns off the spanning tree on the port, it doesn't actually do that. Now let's go and take a look what is happening on the wire between Cat1 and Cat2. To examine that, I'm going to add my Wireshark station to Cat1, which will be connected to Fast Ethernet 03. And I'm going to send a copy of all traffic being sent or received from Gigabit 01 or sent to Gigabit 01 to the Wireshark capture here. So let me go ahead and configure this. So on Cat1, I'm going to say monitor session 1 source interface Gigabit 01, both. I want incoming and outgoing traffic. And then I'm going to say monitor session 1 destination interface Fastnet 03 encapsulation replicate. Then I'm going to go to my Wireshark and I'm going to start the capture. And what I'm seeing here are some frames being sent and received, so I'm going to limit the output to only spanning tree BPDUs. And what I'm seeing here are the BPDUs sent by a host that has a MAC address 5A81. Let's go to a terminal here and see what this is. So if I take a look at Gigabit 01 on Cat2, it seems that only Cat2 is sending the frames here. There are no BPDUs being sent by Cat1. And if I go to Cat1 and I confirm, which shows spanning tree, that this bridge is the root, Gigabit 01 should be sending some frames, but it doesn't send any. So this is how BPDUFilter works when it's configured on the port. Now let's take a look. How is the global configuration different than this one? I have undone all the changes that I have configured on my Cat1 and Cat2, and they are back to their normal state. So on Cat1, if I do show spanning tree, I see that Cat1 is the root and that Gigabit 01 is the designated forwarding port. On Cat2, I can see that Gigabit 01 is the root port. So what I'm going to do next is I'm going to go to Cat1, and in the global configuration mode, I'm going to say spanning tree port fast BPDUFilter default. This is going to enable BPDUFilter on all portfast enabled ports. So with this configuration here, is now BPDUFilter enabled on my Gigabit 01. If I do show spanning tree interface Gigabit 01 detail, I'm not going to see any information about that in this output. Furthermore, I can see that some BPDUs are actually being transmitted. I have also received one BPDU from the other side, and that was when this interface initially came up, when Cat1 and Cat2 were determining who needs to be the root. So let's see if my global configuration actually does anything. I'm going to do the shutdown, and then I'm going to do no shutdown as soon as the interface goes down, and I'm going to repeat my command of show spanning tree interface Gigabit 01 detail, and here I again see that I have received one BPDU. So we can see that this BPDU filter that is configured now globally does not affect Gigabit 01, and it doesn't affect it because it's not a portfast port. Now Gigabit 01 is actually now operating as a static access port, which means that if I globally enable the BPDU filter and if I globally enable portfast, this port should be affected. So what I'm going to do next, I'm going to start by shutting this port down, and then I'm in the global configuration going to say spanning tree portfast default. So now when I bring this interface up, and if I repeat this command here, I will see now that I again have some BPDUs being sent. I also have some BPDUs received here. And I can see also that some BPDUs here are still being transmitted. And I'm going to be seeing these BPDUs being transmitted and transmitted and transmitted on and on and on. And I cannot see that the BPDUFilter is actually active on this port. Well, it's not active because it was turned off. Remember when I talked about the portfast, that any incoming BPDU on the port will reset the portfast state of the port. And because now Gigabit 01 is dependent on the portfast as far as the BPDUFilter goes, the incoming BPDU actually turned off the BPDUFilter. So I'm going to shut this link down now, and on cat2 side, I'm going to say spanning tree BPDUFilter enable on the interface itself. This will prevent cat2 from sending any BPDUs to cat1. And now, if I do no shutdown, and if I repeat my show spanning tree interface detail command, I will see now that I'm receiving no BPDUs. Also, take a look at this. The BPDUFilter is enabled by default, but look, I'm still transmitting some BPDUs. And if I repeat the command, I will see BPDUs being sent here. I have sent 10 so far, 11, and this is where it all stops. When configured globally, the BPDUFilter does not filter any incoming BPDUs as we have seen, and it will filter most of the outgoing BPDUs. In other words, all the outgoing BPDUs except the first 10 or 11. It's actually 10 plus 1. What I mean by that is that 10 are going to be sent to a Cisco proprietary destination in a case of a trunk. In a case of an access port, it will be sent to a standard destination, and 1 will be sent to a Cisco proprietary destination of the per VLAN spanning tree. I talked about it earlier when I introduced the per VLAN spanning tree. I talked about the different addresses used by the standard spanning tree and by the Cisco proprietary per VLAN spanning tree. So here I can see that only a couple of BPDUs are sent to begin with. Now, what would be the purpose of this? Why did Cisco implement this feature in such a way like this? Well, there is a good reason for it. To show you what the reason is, I have to go back to my whiteboard. Imagine two switches are cat1 and cat2. And both of these switches have the port fast enabled by default, and they have the BPDUFilter enabled by default. So the global configuration has been applied on cat1 and cat2. And these two switches are interconnected not with one link, but two links. What will happen here is when these interfaces come up and these interfaces come up, if the BPDUFilter is enabled and the port fast is enabled, this port here is going to become designated, this port is going to become designated, this port is going to become designated, and this one is going to become designated because no BPDUs are being sent. This ends up being forwarding, 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 and forwarding, which means that we actually have a loop in our network. Now, this situation here is why Cisco decided that they're going to try to avoid this loop if the BPDUFilter is enabled globally. How does it work? Well, let's redraw our topology here. So I have cat1, cat2, and two links between them. Again, port fast and the BPDUFilter are enabled by default on this port. Now, Cisco knows that if this configuration is applied on this switch here and on all of these links here, we are going to end up having the previously described problem. So in order to avoid this, Cisco also knows that the port fast is conditional state based on the incoming BPDU. So if there is an incoming BPDU, the port fast state will be reset. And the globally configured BPDUFilter is actually dependent on the port fast. That means that if port fast state gets reset, the BPDUFilter is gone. So when these interfaces here go up, what's going to happen? They're going to start sending a couple of BPDUs. The same thing is going to happen from cat2, and this will have the result of resetting the port fast state on the other switch, in other words, turning the BPDUFilter off. So this configuration here is going to reconverge to be normal spanning tree topology. Let me show you this in action. Remember, cat1 here will be the root. And what I'm going to set up, so this is going to be cat1, this is going to be cat2, and I'm going to have two links between them. I'm going to use two fast Ethernet links. So the top one will be fast Ethernet 24, and the bottom one will be fast Ethernet 23 on both sides. And this one here will be the root. Now, I know what the topology is going to be. This will be the designated port, this will be the designated port. This port will be blocking, and this port here would be the root port. This would be forwarding, this will be forwarding, this would be blocking, and this one here will be forwarding. This is how the spanning tree without the BPDU filter enabled will converge. So let's give this a go. What I have here now is the previously described configuration. I have Cat1 with two interfaces, fast Ethernet 23 and 24, and I can see that these two interfaces are both designated and forwarding. On Cat2, show span shows me what I expect to see. Fast Ethernet 23 is the root port in a forwarding state, and Fast Ethernet 24 is the alternate port in the blocking state. So now what I'm going to do is I'm going to go ahead and I'm going to shut these ports down on Cat2 side. Then in the global configuration, I'm going to say spanning tree port fast default, and I'm going to say spanning tree port fast BPDU filter default. So I'm enabling the port fast and the BPDU filter globally. On Cat1, I'm going to do the same thing. So I'm going to say spanning tree port fast default. I'm going to say spanning tree port fast BPDU filter default. So I have enabled both the port fast and the BPDU filter. Then on Cat2, I'm going to go to my interface range here, and I'm going to prepare the no shutdown. On Cat1, I'm going to say show spanning tree. Actually, I'm going to do one other thing. I'm going to prepare the shutdown, no shutdown on Cat1, because Cat1 is the root in our network. Both ports will end up being forwarding anyways, but I want to show you what happens on Cat2. So here on Cat2, I'm going to say no shutdown. It's going to do nothing because the ports are shut down on the other side, but here I want to prepare my show spanning tree output. And I'm actually going to put it in my copy-paste buffer so that I have it ready there. Now, on Cat1, I'm going to say no shutdown. And here on Cat2, I'm going to start running this command a couple of times. And let me show you what happened here. We can see when the ports initially came up, they were both designated and in forwarding state. This was the result of the configured port fast. Now, as the time moved on, here we can see that spanning tree actually managed to prevent a more permanent loop. The BPDU filter was actually turned off at this stage. Now, on Cat1 here, if I do show spanning tree, interface fast Ethernet 23 detail, I will see that BPDUs are still being sent because the BPDU filter is no longer active on this port. It's conditional on the port fast state of this port.